Alright, so this video is going to introduce you to data structures. So let's start with a simple definition. So data structure is a way to organize large amounts of data inside of your computer. And one of the things that we're going to try to really understand throughout the semester is the difference between an abstraction and a data structure. They do somewhat overlap, especially the way that we talk about them, but they are actually very different things. So an abstraction is best described with an example. So a dynamic array is an abstraction. I know you all know of the dynamic array. So in C++, that would be a vector. That's what the container class is called. And when you use a vector, you know some things about how a vector works. So you know that if you keep adding stuff to it, it will continue to grow, and take care of all of that for you. You know that you can directly access elements in an array. You know that those elements are in order. These are all aspects of the abstraction that you are provided as a user of the container, that you don't have to worry about anything under the hood or any implementation under it. And you know of other abstractions. You know of the idea of a stack, probably, and we're going to talk about it if you don't. And so a stack is this idea that you can only access the last thing that you placed on top of the stack. Or a queue, which is set up so that you only have access to the oldest thing that you put in the stack or in the queue. And then a set, which is very similar to the mathematical set you learned about in your theory class. And then a map, which is a key value pair. So all five of these you might have heard of, you might not have, but there are all these abstractions in these types of structures that have all this functionality. So how those are actually implemented is with various data structures, and there's lots of different ways you could implement lots of different abstractions, so there's not like a one-to-one correspondence between these. And so the data structure is actually how the data is stored on the machine. So in memory, for example. So an array, you know that when you put something in like a C array, for example, that you're kind of allocating some space in memory and it's all next to each other. So it's all sequential, and you have that, and that's where your data is. You also are familiar with setting up something like a linked list. So a linked list is maybe where you have some nodes or some structs that link to each other, and so all of the data is wherever it wants to be in memory. It doesn't need to all be together, but then it's all linked. A tree is also a linked structure, but instead of having just that linear linkage that a linked list has, it can link to multiple nodes. It has this hierarchy that it's like top down. Binary trees always link to 2 nodes, but there's trees that could link to as many nodes as you'd like. And then a graph, so a tree is a subset of a graph, is also a linked structure. Although it's a little bit more general, you have a bunch of nodes, and those nodes can connect to any other node, and there's not like a head node that does this top-down thing like a tree does. So a tree is a subset of a graph. So these are all just different ways that you can place data in memory and connect it all or know where it is. And that's what a data structure is, and that's what we're going to learn about. Now, I didn't show you a hash table. It's a little bit harder to explain. A hash table is also something that you're going to learn about as one of the 5 major data structures that we're going to focus on. And it's like basically magic because it uses hash functions to magically find a place in memory. It's not really magic, it's just math, but it's pretty cool. So we're going to talk about that later. So abstractions versus data structures, that's a little bit about that. So why does this matter? Data structures, the choice of your data structure really impacts your problem solution because it is a huge factor in the efficiency of your program. So how long it takes to run it, how much space it takes up in memory. It impacts your algorithm choice. because some data structures lend themselves better to different algorithms. It impacts how difficult it is to program. Choosing the right data structure can really simplify your code and make it quite beautiful, which then leads to readability and understandability of your code. So choosing the right data structure can just make your code a lot nicer. One of the things that we're going to come back to all the time, we spend a whole week on it early on, and then we literally spend every other week on it, at least a little bit of every other week, is complexity. So complexity analysis sounds really fancy, and it's not at all. It's also known as Big O analysis, and all it is understanding how efficient your program is. So the idea is if you have data, and let's say you have 100 pieces of data in your structure, and then you increase it to have 1,000,000 pieces of data in your data structure. What's the cost? How expensive is that going to be when you make the data structure contain more things? How much is it going to impact space and memory, and how much is it going to impact time? And we call this Big O because we use this notation of O with like a mathematical function in it, and the mathematical function represents this curve, which is just saying how expensive it is. So everything in this pink color is really expensive, and it's so bad that it's you can't even use it in real problems. And then you know, the lower this curve, the better, because it basically means you can keep putting more and more data. You can keep solving bigger and bigger problems with this algorithm or this code, and it's not going to get, you know, much more expensive to run. So one of the complexities we like is O1, because O1 means that it takes one. It's only one access. It's only moving one thing. It's only pulling one thing from a structure. One means that it's constant. It means that it's the same cost if you have an array of 10 or an array of 100 or an array of 1,000. No matter how many things you have in it, the cost is constant for that operation. So an example of this is to review a structure that you're really familiar with, which is an array. And there's one defining characteristic of an array that we love, and it's why we use them so much. So this is referring to O1 again. So remember, O1 just means it's constant. So it doesn't matter how big this array is. This operation always is constant. It's always just costs 1. So pause the video and just take a second to think about it, and then I'll talk about it. Okay, so the answer to this is that the defining characteristic of an array is that it has O1 access to any element. So what does that mean? If I want the 4th element in the array, the 4th index or the 4th actual item, so let's just say it's the 4th actual item, then I can have that, and it's direct access with O1 time, right? Now, what's an example of a data structure that doesn't have this? Well, a linked list, right? With a linked list, if I want the 4th, I have to walk through the linked list to get the 4th, and so it's not O1. And so if I need to get the 100th in a linked list, that's a lot more expensive, right? Where in an array, getting the 4th, getting the 100th, getting the 1,000,000th element, they all cost the same. So this isn't true because it's not that you only have access to the first and the last, which is often the case with the linked list. It's that you have access to any element, direct access. Now what about insertion? So what's the cost of insertion? So insertion is expensive in an array because if I want to insert something right here, I have to grab this entire chunk of the array, everything after, and I have to shift it over by 1 to leave space to insert something, right? And that's an expensive operation because if it's a lot of data, it's a lot of data to shift, so it's not O1 to insert at any position except for it's cheap to insert on the last position. So this is what you're going to be thinking about a lot in this class, and so this gives you a little bit of a sense of it with some data structures that you're already familiar with. So that is it for this video. Thank you so much.